partial differential equation. So we are going to look at it briefly. Okay, you are all welcome. We won't have a wonderful class. All the best. Okay, you are all welcome. Tonight we are going to look at this idiot. Amen. Amen. Yeah, viewers all over the world, you are welcome to tonight's class. It's going to be brief. We'll be looking at formation of PDE. How can we form PDE? As simple as ABC. We'll be using elimination method. We have two types of formation. We have substitution and elimination, but in this video I will be using elimination method, how to form PDE to eliminate the arbitrary constant. Amen. What do I mean by arbitrary constants? We are talking about this A and B, the arbitrary constant. Is that clear? We have arbitrary constant and arbitrary functions. You know what functions is all about. When we have something of this form, this is a function, a statement. Then we refer this as what? Arbitrary constant. Is that clear? So let's proceed further to do what I want to do tonight. Here is the question. Find the PD of all sphere whose center lies on z-axis and given by equation x squared plus y squared plus 2z minus a plus bracket raised to the power of 2 equals to b, where a and b are constant. Amen? Amen. Okay. So if you can see what I am saying, it is not difficult. So let's write solution. Solution x squared plus y squared plus z minus a all squared equals to what? B. Yeah, for the fact that it is z axis, it means we are going to differentiate this idiot, this equation partially with respect to 1. How many functions do we have? 1. We have x, y. 1 with respect to x, 2 with respect to y. Amen? Amen. Okay, so let's differentiate this idiot. So this implies that partial all over partial z, then all in brackets x squared plus partial all over partial z, all in brackets y squared plus partial all over partial z, open bracket z minus a all in square. Amen. Amen. Equals to partial z times b. Okay. We are to differentiate this partially with respect to what? X. So what we need to do is we are going to differentiate only those functions that contains x. So any other thing will be 0. True of us is true. Okay. So if we differentiate these idiots, we are going to have here we are going to have 2x, here is 0, plus if you differentiate this, we are going to have, okay? Yeah, not necessarily you can present it in this form. Yeah, let's do it straight. If we differentiate this partially with respect to x, we are going to have 2x, then plus here, we are going to have 2 open bracket z minus x partial x all over partial z. Then this is equals to 0. I know you want to ask why this is 0, because this is a constant, so this must be 0. So now we are able to differentiate this function with respect to x. So what we need to do, we have to differentiate this equation with respect to y, the same thing applicable here. So it means here will be, here we are going to have what? Okay, at first, let's do something here. Let us do something here. If we divide through by 2, here, if we divide through by 2 at this point, divide through by 2, it means we are going to have 2 cancel 2x all over 2 plus 2 all over 2 open bracket z minus a partial x all over partial z is equals to 0. This and this will cancel. This cancel. It means we are going to have x plus z open bracket z minus a partial x all over partial z equals to 0. Amen. So you don't need a prophet to tell you. Yeah, you don't need a prophet to tell you. By the time this idiot crosses the sign of equality, we have z minus a open brackets partial z equals to minus x. True or false? True. Yeah. But note that as long as PD is concerned, note that partial x all over partial z is equals to p, and partial y all over partial z is equals to q. So what are we going to write here? Here we are going to have z minus a instead of partial z all over partial x all over partial z. We write p equals to minus x. So when we make this idiot the subject of the formula, amen, z minus a, it means our z minus a will now become minus x all over what? P. Are you following? Do you understand? Okay. So far, so good. So it means we are going to do the same thing to x, y. You don't need a prophet to tell you. We are going to differentiate this idiot with respect to y. So it means here will be 0. Here we are going to have 2y. Then plus, if we differentiate here with respect to y, we are going to have 2 open bracket partial y with respect to partial y all over z equals, if we differentiate b, it will be 0. True or false? Okay? Yeah. So the same thing applicable here. Divide through by what? 2. When we divide through by 2, divide through by 2. Okay. So we are going to have 2y all over 2 plus 2 all over 2. Amen? Amen. Amen. Minus z partial y all over partial z equals to 0. Any question? Do you have any question? Please drop it in the comment section. I'll be very glad. Yeah, Lolly. How are you? Where are you watching from? Which country? Okay, so let's proceed. Yeah, so far so good. you don't need a prophet to tell you. Here we are going to have y plus y plus z minus a partial y all over partial z equals to 0. But you know, I mentioned it to you that this is as long as PD is concerned, partial y all over partial z is q. So here instead of this we are going to write q, but by the time we take this y to this left hand side, we are going to have, or we just leave it like this, y open bracket z q equals to this. Okay, yeah. So what to form, we are, all these things we are doing, we are trying to form PD. So now, here, you don't need a prophet to tell you. What are we going to do here? Already we have this. So we can now say, write that, let's make this one, this is equation, okay, this is equation 1. Let's make this one equation 2. Then we now say, putting, amen, putting z minus y equals, because our z minus y is equals to minus x all over p. Amen? Amen. Okay? So far, so good. So if you can see, putting z equals to this into equation 2. Yes, so if we can do that, or you can see what I am saying, both in the spirit and physical, mathematically. Amen. Life of mathematics is always beautiful with Mr. O.C. It's okay. So let's proceed. It means instead of this, we write minus this in equation 2. Y plus open bracket minus x all over p times q equals to what? 0. You don't need a prophet to tell you. Y minus, open this bracket, x times q will be xq or qx all over p. Amen? Amen. Okay, so you either leave it in this form, or you, by the time you take LCM, you see the same thing as or by the time you take LCM, here we are going to have yp minus xq all over p equals to 0. Yeah, so far so good. This is how, this is how you are going to form it. Look at the board and tell me if you have any question. Drop it in the comment section. Yeah. Lolly, which country are you watching from? May I know the country you are watching from? Which country? Which country? So this is how you are going to form this PD should, in case you come across this. Any question? No question. Okay, let's proceed further to solve more questions. Yeah. Let's proceed further to solve more questions. Okay, so far so good. We'll be looking at, yeah. We'll be looking at Okay, yeah. Let's consider double integrals. Amen. Amen. Double integrals. We'll be looking at double integrals. Okay. Double integral. Double integral. Okay. Double integral. What we want to do is all about elementary calculus. If you know your elementary calculus, it's very simple. Not mind the cock that is disturbing the class. Oh wow, they are taking the lights. Sorry about it. It's okay. Yeah, so we can continue. Okay. Sorry for the break in transmission. Double integrals, as long as calculus is concerned. When we say double integrals, I know you'll be solving single integrals, two of us, yeah, in calculus. But as long as calculus and advanced calculus is concerned, you must consider double integrals. Let us look at when we have an integral of this form. This is a single integral. Amen? Amen. Then let us assume that this one is running from A to B. So this integral, we can refer this integral as what? Definite integral. But by the time we have integral running from A to B, then in another integral C to D, then we now have either arrow or the theta, arrow the arrow, then times the theta. You can now see that this is a double integral. Amen? Amen. This is a double integral. Yeah. So, it's the same thing. You are going to integrate the single integral. You apply the same method to integrate this double integral. It's not difficult. So, let's look at it. And I'm not going to solve everything. I will stop at some point, then you finish it. Is that clear? I want you to finish it. Okay, so let's go ahead and solve this problem. It's okay. Let's say evaluate integral theta equals to 0, then pi all over 4. Can you see now? Then another integral arrow equals to 0 to 3 cos 2 theta. Amen? Amen. Okay? Arrow the arrow times the theta. Amen? Okay. So far so good. It is not difficult, as simple as ABC. Yeah. So what we need to do here is let's write solution We now write the integral, double integral, theta equals to 0, then pi all over 4, and this is r equals to 0, and here is 3 cos 2 theta, amen? Then r dot the theta, the r times the theta is okay. Let me break it down for you, amen? Okay, so when you come across double integrals of this form, first thing you should consider is first integrate this first integral. Which is what? It has to do with what? Arrow the arrow. Amen? Amen. So here, if we integrate arrow the arrow, we are going to have this integral will remain constant. So you write the integral first. Theta equals to 0 pi all over 4. Is that clear? Possibly you can open the bracket for this. Then we'll now write, if you integrate arrow the arrow, mind you, this the theta will be what? Held constant. Why? Because look at its integral here. Is that clear? So you just after arrow the arrow. So when you integrate arrow the arrow, you are going to have arrow raised to the power of 1 plus 1 all over what? 1 plus 1. You remember that in elementary calculus, when you integrate single definite integral, you are going to have at. Instead of this integral, it will now turn to what? At arrow equals to 0, then to what? Running from arrow to 0 to 3 cos 2 theta. Then, mind you, don't forget the theta times the theta. Amen? Are you following? Do you understand? Are you following? Okay. So, what we need to do here is, you don't need a prophet to tell you. Here we are going to have, okay, integral theta to 0 pi all over 4. Not this one. Now so. Okay. So open bracket. Okay. R raised to power 2 all over 2 at arrow to 0. Then 3 cos 2 theta. The theta. Yeah. Okay. So it means anywhere we see arrow, but we are going to subtract this lower limit from the upper limit. So it means this is what it will be. Integral theta to 0 pi all over 4. But do you agree with me that pi is always equals to what? 180. True or false? Huh? True or false? It's okay. Here, subtract this. Already, since this is 0, here will be, you are going to have 3 cos, amen, 2, all in bracket, since r is raised to power 2, 2 minus, our arrow is what? 0. It means, here, look at it, 0 square all over 2, then all in bracket the theta, amen. Okay, yeah. So you can now see that already here is 0, true or false? So here is the same thing as integral theta equals to 0 pi all over 4. Then here we are going to have here 9 cos square 2 theta, then here is 0. Open bracket, close bracket, the theta. So at this point, you need to what? Integrate this function, then substitute, subtract the lower limit from the upper limit. So this is where I'm going to stop. I want you to continue from here. In my next video, I'm going to finish it. Is that clear? If you have any question, drop it in the comment section. Any question? Oh, this is double integrals. My friend, Tanish Mandavkar, how are you? Where are you watching from? Which country? This is mathematics, advanced mathematics. This is advanced mathematics. Which country are you watching from? Oh, my friend, Tanish, which country? It's okay. So far, so good. Gentlemen and ladies, I'm going to stop here. But should in case you have any question, you can reach out to me through this number. This is my WhatsApp number, 33667737. You can reach out to me in case you have any mathematical problem. Reach out to me, I will get back to you. Thank you. Please make sure you like, comment, and subscribe. Love you. Bye.